Yes.
Here we can see our Maya interface. This subject is also for beginners in the Maya, and I'm going to show you every part of the interface and how we can work with Maya. First, you will see our scene. In the scene, we are going to create our objects and visual effects. In the right part, we have channel box. We have attribute editor. We are going to use this tool every time. We are going to work with the attributes of with the effects and change them. And in the channel box, we are going to see coordinates and make some animation around them. In the left side we have outliner. In the outliner it's like a history of what consists in the stand. For example, if we add some objects, here we will see these objects, effects, and this is also needed window. If it close, you can go to the windows and outliner. With the outliner we are going to manage our scene and the objects in this scene. Also we have some tools here. This is for selection, this is also for selections, and this is the move tool, rotate and scale. And here we have some different layouts of the camera. In the Maya we have perspective camera and 3 orthographic camera. We can see them inside of outliner. This cameras is also by the default, and we will use some perspective view mostly. When we press space on the keyboard, we can switch between these 4 views and single view. Whereas the pointer of mouse, it means we can open this window. Maybe you have some difference text here. It can be perspective, front view, side view, and the top view. Here you can see these stats. These stats I am open every time when I model. You can go to display, HDAPS display, poly count, and switch off or switch on this HDAPS display with the poly count. Poly count is just needed when you make some modeling. Those who have object modeling can use this poly count, but for the VFX effect it's not needed. We can switch off this in the interface. And also we can change the workspace according to our purpose. For example, when we work with the rigging animations, we can switch and change this layout of the windows. But I suggest you to use this general layout workspace. With the general layout we have all necessary windows here, and we don't need to change it for the VFX purpose. We can also open modeling standard. If you change something here with the layout, you can see this different kind of setup in Maya. For example, when in the general view I didn't see this switcher, that's why I should find this general. I think will be more comfortable for the work, and I will use this one. Here is this outliner, attribute editor, channel box, timeline, and this necessary setup. In the Maya we have different kind of folders where we have tools. For the for the modeling purpose, we have this mesh, edit mesh, mesh tool, mesh display, cursor, and etc. For the visual effects, we will use FX menu. With the FX menu, we have particles, fluids, and clothes and hair. That's why I'm using this workspace setup with this switcher, which can allows me to change this menu according to the purpose. For example, when we are going to render our effects, we will switch to the rendering, and now we can switch to the modeling. First, we need to prepare our objects for the visual effects. In the sorry. For the visual effects, we need also objects, which is will be our layout and setup for visual effects. And first, we can create some primitive objects. For example, we can add our polygon sphere, and now we can see this object in scene. When we select this object, in the channel box we have these attributes, which means translate, rotate, scale, and we can change it in the channel box, or we can change them by using these tools. We have move tool, and you can see these gizmos for the moving this object around this scene. In the scene we have some grid. This grid is like a supported guidelines to understand where we in the perspective. This grid like a graph in our 3D world. To manipulate and observe the scene, I'm use Alt and left mouse button. By using this Alt and left mouse button, I can observe these objects around. By pressing Alt and middle mouse button, I can pan this scene, and Alt with the right mouse button, I can zoom in and zoom out. And also I can use some key shortcuts for the focus on the object. When you press F on the keyboard, you can focus on selected object. You can select objects in outliner and press F. For example, like this is really small, and you can press F and it can be focused on this object. And now when we press Alt and left mouse button, we can observe around this focused object. These shortcuts work only if your keyboard in the English language. If it's in other language, it's not working, for example. You should change the language into the English, and now you can use shortcuts. The shortcuts for the rotation is E on the keyboard. When you press E or Y on the keyboard, you can rotate this object. When you press R on the keyboard, you can scale this object according to this axis. And also you can change positions in the channel box and refresh them. Okay, now we have this object. You can use these tools for manipulations, or you can press W, E, R, and you can use these shortcuts. And also you can use these tool tips when you hover with the mouse with the small seconds. You can see here this is the move tool and W for the shortcut, E and R for the scale tool. Now next, what we can do with this object. When you will be on the modeling classes, you can learn how to model this object and manipulate with this object. Now for this small tutorial, we need to create the plate from this sphere. I can press right mouse button and change the view of this object. We can go when the object is green, it means this is the object mode. When we switch to the faces, now we can select faces and manipulate with them directly instead of the full object. We can manipulate with its components like a face. We can manipulate with the vertices. Vertex, it means like our points in the object. Every object consists of these polygons. That's why it means polygonal modeling or polygonal objects. And these polygons have edges, vertices, and we can work with these edges and make some modeling process by using and applying some tool on these polygon primitives. And also we can select with when I press double click on left mouse button and press shift, it can be select loop of these faces, and we can delete this loop of faces by pressing backspace. And with a double click we can select objects which is connected with the edges or vertices. And this edge is not connected anymore, that's why we can delete not necessary parts. And now we have this simple plate by using only selection and component selection of this object. By pressing right mouse button you can access every time in this menu and change selection mode, vertex or edge or faces, or again object mode. Now let's move to our first visual effects. When you finish with the preparing steps with these objects, we can save this file file saves in us. We can create new folder, name this file, and now it saves. Maya is really not stable program, even especially when we work with visual effects. That's why you should press Ctrl S every time without from every changes to save your progress. Because when you work with the visual effects, it can be really huge for your computer, and it can be interrupt anytime. That's why you should press Ctrl S every time when you change something. Okay, let's move to FX folder and find some end particles. We are going to use these end particle systems to create some visual effects, which is used some for example, like snow, like small objects. We can create some emitter, and from this emitter, when we press play, these particles emitted during our animation. We have this timeline. In the Maya, we have 24 frames per second. We can use this setup for our field. It means during 1 second we emitted 100 particles. And here in the outliner now you can see another objects instead of sphere. Here we have some emitter, and this emitter we can go to the attribute editor. In the attribute editor we have emitter. In this emitter we have attribute like rate, particles per second, and you can calculate how many particles you need per second. Seconds, it will be our timeline. For example, 1 second it's only 24 frames, And we can manage this timeline and make it set up our duration. For example, if we need some 10 seconds, 10 seconds, it means 240 frames. These 10 seconds can be something like this. And this is the simulation of these 10 seconds. And also we can open the animation preferences here, and we can set up our time slider, and we can change playback speed. We can say play every frame. It will be more convenient for these visual effects. For example, the simulations calculating every frame. That's why we need to play this every frame for perfect calculation of these simulations. Or it can be 24 per second. It will be real-time animation. For example, if you have really powerful computer, your animation play every frame will be really fast and not like in the real time. It can be faster than 24 per frame, but if you change it for the 24, it should be more natural. But if you don't have a really huge and powerful computer, you should use play every frame, because if you choose 24 per frame and the calculation can be not actual, your visual effects can be crashed or maybe not calculated perfectly. That's why I'm using this play every frame here. And now we can see this animation. This is 10-second animation, and it means for the 10 seconds we have almost 5,000 particles in the stand. Particles, it's this is small points here, and we can change this rate. For example, if we set only 100 particles per frame, it will be less particles. If you want to more particles, you can put some more particles here, and it can be some salt or maybe sugar. And now this is really slow simulation. If you have even more particles here in the stand, we have much more OZU and much more RAM and power to provide this simulation. And also I'm using this go to start playback range button to refresh this simulation. If you will use this pointer, your simulation can be crashed, even Maya can be crashed. But use this to go back to the first frame. And let's play and again see how it looks like. This is really frozy now and powerful. Okay, let's change it for the convenient quantity and even less. Okay, let's use this emitter, and now you can see my emitter looks like a box. When you first create your emitter, it can be not volume, it can be omni. Omni emitter, it means you just let's sphere move back. Omni emitter, it's like a small point, and from this small point particles are emitted. You can change this to directional, you can change it to the volume, and volume you can change, for example, when it's cube, from this cube can be emitted. If you change to the sphere, from this sphere it can be emitted. For the snow globe, we are going to use this sphere emitter. But now we can switch emitter type to the omni by the default, and when we play, it's like one origin for these entire particles. Okay, let's put this origin somewhere above this plate, and let's try to fill this plate with these particles. Now these particles are fall through this plate, because this plate is not in the physical world of the Maya. This plate don't have any attributes like the collisions. We can apply the collisions by using this enclose folder and applying create passive collider. By applying this passive collider, this plate becomes collider and have this attribute like a collisions. And we can use these collisions, and now by the default particles have collisions with the objects who also have collisions. And now we can fill this plate, but particles by the default don't have collisions between together, and they intersect each other. We can in outliner we can choose and particles and go to the collisions folder in the attribute editor and particle shape and find self collide attribute, and let's go back to the first frame, and when we press, now every particles collected together. But now you can see these gaps around these particles. These particles really small, but this size have radius, the big radius. If you change this radius, it can be more like paper or salt, and you should have a lot of time to fill this plate. And we can also change the particles particle shape. We can go to the particle also particle shape and find some shading folder. In the shading we can change particles to the points or spheres. If we change it for the spheres, now these particles becomes like a small spheres, and this radius, if we change it, we can make it bigger. It can be more like bubbles or maybe some candies, and we can fill quite faster this plate with the particles. And when we fill it, we can switch off this simulation. For example, we can make some animation to the particles attributes. On every particle attribute we can create some animation. What it means, animation? Animation, let's start with the plate animation. For example, let's go back to the first plate and make some movement animation for this plate. For example, after 100 frames, this plate can moves and empty this plate with the rotation. How we can use animation? In the channel box we have these attributes, and we can set key on these attributes according to this timeline. Animation, it means changing during changing positions of the objects during the time, and we need this timeline. And if you need to create fast animation, you can use small frames between the changes. If you need small animation, you need more time between changes. That's why you need more frames between them. Let's create the first keyframe on the 100th frame. We can press S on the keyboard. It means we created the keyframe for all of these positions in the channel box for this object, selected object. And if we can switch on after keyframe toggle, it means when you change a frame and change position, it can be automatically set key on the changes. For example, we change only the rotation on the x-axis, and it means we set keyframe on this rotation object. Animation is a curve. We can open graph editor in the Windows animation editor, graph editor, and see these changes. It means we have this automatical animation between on the rotation of x between 20 frames, and this difference calls animations. And we can see if we press, now we can see this animation. Plate is full, and now it's changing. And we created this rotation of the plate during 1 second. If you need to move faster, you can select with the shift this keyframe and move it closer to the origin. And now we have 10 frames between these changes, and it will be a little bit faster, like this. And the second step, I'm going to switch off this emitter when the plate is full before animation. And now we need to go back to 90 frames, for example, or 95 frames. We can select it, or we can type needed frame. Let's set key on this attribute. With the right mouse button we can set key, and on the next frame we can change it to the 0 and also set key. Or if you have automatically keyframe toggle, it can automatically record this animation. And now if we press play entire simulation, we have this small effect. For example, we should stop simulating even earlier. And now we can plan our scenario here and put it like this. And we can put here another plate and make some motion graphics here with some small idea of this simulation. Or we can just put some plane like a table, move it maybe here. And also for this plane, if you want to work, if you want to particles not intersect this plane, we should also add passive collider for this plane and create this passive collider for the plane. And now we have this animation. And that's all for this small practice with the particles. And during this small practice we'll learn how to create emitter, how we can animate these attributes for the emitter. We can change the shape of the particles, and also we can change even the color of these particles. We can put it like candies. Maybe we can change even, create even the gradient for them. It can change, for example, during the age. First it can be red, after that it can be pink, or it can be maybe some randomized ID. Some of them can be red, some of them can be pink. And also, what can we do? We learn how to apply some colliders to objects to make them interactable with the particles. And also we can change the particles, how it looks like. We can change its points, multi-points, some multi-strake, Spheres is more suitable for this case, I guess. And also we can switch on self-collide to become these particles collide with each other. And do you have any questions by now? You should repeat this effect on the practice and show this effect to the Dana.
I have a question.
Mhm.
Is it possible to turn on the autosave, or should we save manually every time?
Yes, we can. You can switch on after save because uh, it's. But this after save is not trustable. I think I have cases when it's not saved correctly. That's why I'm. For me, I'm using just Control S when I change something, and you also can go to the some preferences. Here I think here will be some autosave, but autosave works when you uh, save your work somewhere. When you start, just save your work, and where is autosave? Autosave folder in the temp folder sometimes, and when you open it again, it show you where files was saved. Here is autosave. You can enable this and set interval for the saving. For example, you have can be 3 minutes. Every 3 minutes it can be autosaved. And also save. As we open this setting preferences, you can go to the settings uh, and find some undo and press this key to infinite. Undo, it means you press Ctrl Z, and if it finite, you only can be several times undo, but sometimes it needed to infinite. It's really useful to change this queue to infinite. Okay, I think we've done for today. If you don't have any questions, we can um, continue on the next lecture with more VFX and this small practice for your next week, next practice. You can check with this small work how your Maya works, how your computer works, and we can troubleshoot some if you have some problems on this step. I'm stopping this recording now and